So we have total 4 units, right? Unit 1, Unit 2, Unit 3, and Unit 4. We didn't task the unit number 1, right? Unit number 1 is we need to solve some algebraic and non-algebraic equations, right? Algebraic equations means where we have no any functions of trigonometric functions. There is no any exponential function. Right, this type of equation is called the algebraic equation. For example, x square plus 2x plus 1 is equal to 0. These are the algebraic equations. Now, what about the non-algebraic? Where we have the combinations of logarithm functions along with the algebraic function. This is called as a transcendental equations. Okay. Now from the class 7, 8 onwards, what we did in the class 8, 9, 10 onwards, we try to solve, suppose x square plus 2x plus 1 is equal to 0, right? We try to solve this type of equation. This is a completely algebraic equation. There is no any combinations of sine, cos, exponential, right? Now, if it is in this format, we don't have any difficulties. We can get the value of x square. Now, if I do the increment here, x cube plus 2y x square plus 4x plus 1 is equal to 0. In that case also, we don't have any difficulties. We can't do that, right? We can do that. So there is no any issues. So we can find out the solutions by our 10 plus 2 methods. We can find out the value of x here. So these are called the algebraic. These are called the algebraic equations. Now, in engineering equations, it may be the equation may be like this. Suppose the equation may be like this. I need to find out cos x plus e to the power x square is equal to 0 sometime. It may be here, right? So in our basic 10 plus 2 level, we have this. These are called the algebraic equations, right? Now, in engineering study, it may be combinations of sine, cosine, exponential, logarithm. Number of functions may be come up in our equation. This type of equation is known as transcendental equations. Now, you may feel that then what is the use of whatever we had in the 10 plus 2 level? These methods, whatever we had, it is not going to be implemented if it is a transcendental equations. Got the point? Whatever we did in the 10 plus 2 level, we are not able to solve, right, our transcendental equations. That's why we want to solve transcendental or algebraic equation with the help of numerical methods. So I have very systematic slide here, along with I'll do the calculations here. Now here, just try to understand one more important thing is that this topic is very much important for the case of GATE examinations. Every year you can get 1 or 2 questions from this unit number 1, right? We can get bisection methods, seconds methods, Newton-Raphson methods. Every time you can get the 1 or 2 questions from these topics. And from the unit number 3 and 4, from that unit also you can get at least 2 or 3 questions in every year in the GATE examination. That's why I am not trying to solve only the problem here. I am trying to explain the geometrical significance, how it is, and how we can design the algorithm. What is the advantage, what is the disadvantage, I am going to discuss here. Now, before that, I need the basic concept from your side. What you did in 10 plus 2 level. Most of the case, what we do that, suppose I have algebraic equation. Suppose I have algebraic equation in 10 plus 2. For example, suppose I have, it is common for all of us because all of us do like this. For example, most of the questions we ask like this, solve, right, a x square bx plus c is equal to 0. Most of us do these questions, right? Solve it, and we can get, this is, we know that, right? x is equal to this. This is the formulas are here. But what is the geometrical meaning of this one? It means that basically it is f of x is equal to 0. Am I right here? Yes or no? Now we represent this is, we write y is equal to f of x. Here x is the independent variable and y is the dependent variable. Same concept I need to apply to understand the numerical technique. Then I can develop the algorithm. Then only I can apply in our MATLAB programming. So don't expect in the MATLAB programming I'm going to write algorithms. I'll write the algorithms in the class, in theory classes, right? In the MATLAB class, in between for loop and end, I have to put this algorithm. That concept I want to put you here now. Now think here. You can get a slide very systematic line by line, but I don't want to read the slide. So it means that if I want to figure, for example, if I want to plot, this is x and this is, right? Can I get this one? If I put the value of x naught, I can get y naught. Then I can get some data set and I can plot this one in the MATLAB within the fraction seconds are here. Now, for example, it is not necessary the value of x is only positive. The value of x may be negative. The value of x may be negative here. Now, from 0, 1, 2, 3, we increase like this, right? -1, -2, -3, or like this we'll do here. This is the concept we want to apply in our numerical technique. But most of the schools, we don't do that how we solve the function in the above function, right? Our function is ax square plus bx plus c is equal to 0. Means y is equal to 0. It means f of x is equal to 0. Right? I hope it is clear, right? Now come up here. Now, suppose I have one graph like this. Any of the function, right? This is y is equal to f of x. Is it okay? Y is equal to f of x. Now, what is the meaning of f of x is equal to 0 in this graph? Where the function is intersect with the x-axis. See here, right? F of x is equal to 0. Here, f of x is equal to 0. Here, f of x is equal to 0. Suppose if I consider this is the interval A and this is the interval B, how many solutions I have here? 3. I have 3 solutions. It means it is a cubical equations. It may be ax cube plus bx square plus cx plus d is equal to 0. It may be, right? It means that what you did in the 10 plus 2 was that I am looking for the value of x where the graph cross-sect with the x-axis. This was the physical meaning of what you did. Now here, if I want to solve this equation, what does it mean? We are looking the value of x where the graph intersect the x-axis. These type of questions will come in the GATE examination. They are not asking to solve ax square plus bx plus c is equal to 0. They assume all of us can solve this one. Identify the point. This type of question will come. Or in the GATE exam, four options, all are correct, but which one is the most accurate? You become very like this one. So I hope now, if your concept is clear here, now we can go ahead, solve the equation. Means we are looking the value of x where the function intersect the x-axis. Okay. Now, in the case of algebraic, no issues. So I can get exactly, suppose this is the value of x minus 1. Suppose this is the value of x naught. This is the value of x1. These are the solutions. Means these are called the root of the equation. Am I right? Root of the equations. Fine. Now in our case, it is become cos x plus e to the power x plus x is equal to 0. Am I right? In that case, if there is a cos function and sine function, sine and cos can intersect the x-axis infinite number of times. Yes or no? Because at different point of value of x, the graph is going to cross-sect the x-axis. I hope in the last lab classes, I took y is equal to sine x, and I took x-axis from 0 to 1000. Have you seen the graph? How many times it cross-sect the x-axis? Yes or no? How many times it cross-sect the x-axis? Is it clear? This will come up now if it is not algebraic. If it is not algebraic, which is transcendental equation, which one is the perfect root of the given transcendental equations, and how it has to be decided as per our requirement. This is our challenge. But graphical concept, I hope now you have understood here. This is the graphical concept and how we can identify here. Now, thing is that next I want to draw one more graph here. Now, I have this is, now I assume that you can understand this is now, and this is right, come up here. And this is our y is equal to f of x, right? Now, we can decide the interval in the x-axis, right? Now, if I take, this is one interval, suppose A, and this is another interval, this is B. In these two intervals, how many solutions I have? I have two solutions. One is here and another is here. Means there is there. If it is algebraic equations, I can set quadratic. But in terms of transcendental, I don't know. There may be this one. Now, questions is that. First questions in the gate they ask these questions, right? At what situation? At what conditions I can say that in the interval A and B, there is at least one solution. So here I have took interval, close interval A and B, including A and B, right? At what condition, right? What is the condition? What is the condition? What is the condition, right? To get at least one root in interval A and B. At what situation I'm very much confirmed, at least one solution, there may be more than one. Right? Very simple condition here. To get a solution, to get at least one solution in that interval, the graph has to cross x-axis at least one time. Got the point? To get the at least one solution, the graph has to cross-sect the x-axis at least one time. Why? Because f of x is equal to 0 should be there. So this type of small questions will come up here, that the foundation should be clear, then only I can write in examination 15. And they are not asking to find out the root this one. They will ask graphical representations. They may give the some graphs. They may ask this condition here. Now, very interesting case here, that this is of course, I have very much confidence and I have confirmed if the graph at least cross-sect the x-axis. Very much confirmed. So here it has cross-sect 2 times. Now take one thing here. I am taking here now another 2 points. Suppose I am taking here another 2 points. Suppose this is B and suppose this is another interval C. In the interval B and C, there is no root, right? But I'm very confused. It doesn't mean that. See, above the x-axis means f of x is positive, right? Above the x-axis means f of x is negative. Below that is negative, above is positive. Now, case is that if in the interval A and B, if the value of functions are opposite to each other, right? In the interval A and B, if the value of the function is opposite to each other, then I am very confirmed there is at least one root. So this condition has to be right here answer, right? Second condition is that I am taking another here B and C, right? Here another B and C. Again, I am taking here another points here. Suppose here A and B. Suppose I took another interval, right? Look here. Here f of A is positive, yes or no? Right? Here f of B also positive. Yes or no? I cannot say that there is no root. If the value of the functions in the interval are equal, there may be, may not be roots. Have you seen here? In the interval A and B, there are two roots because it cross-sec 2 times the x-axis. Concept clear? But take another example, B and C, right? Where the value of f of B is positive and value of f of C also positive. So it is, we have confusion, right? It means that in the engineering calculations, we are not going to take any risk that if the value of the function is opposite to each other, then only we will accept there is at least one root. Because there is a confirm there is a root. Because they're opposite to each other. It may be cross-checked 3 times, does not matter, but there is one root. But if the value of the functions in the interval are not opposite, they are equal to each other, there may be, may not be roots. Clear? It does not matter if there is root, it should cross-check the x-axis. Then only there is a solution. That's why engineering problems, if we develop the algorithm, what is the condition? The value of the functions in the given interval should be opposite to each other, right? Otherwise, what happened? If the value of the functions are equal, we are confused, right? That's why in the program we write if condition can be applied, if f of A and f of B are opposite, then I have to go. Otherwise, program will stop automatically. Got the point? Now, this type of concept is required in graphical representation here. The first condition is that if there is a root, the value of the function should be opposite at that particular interval. Second condition is that the function should be continuous. Why it is? For example, I'm just drawing the all here. For example, one function go on like this and one function go on like this. And I am taking the interval. They are not intersecting each other. Or if I take this here, right? Here, what is f of A? Negative. Where it is positive. Right? If the function is not continuous, here they are not continuous function. It is one function, it is one function. They are not continuous. The function is not continuous. If it is not continuous, then previous condition is not going to be implemented. Look here, the value of the function is negative, value of the function is positive. This type of example is if f of x is equal to 1 by x. This is a discontinuous function. So this type of graph we can get here. Though the value of the function is opposite to each other in the A and B interval, but they are not cross-check the x-axis. They are not cross-checking the x-axis means there is no such value of x where it is 0. There is no 0 because it is coming like this and it is coming like this. So this is the basic. Generally, this topic is reviewed. So this is not in our syllabus, but this concept is called the discussed rule, the 10+2, right? So how we can cross-check that the solution exists at what condition? Condition number 1, function should be continuous. Condition number 2, the value of the function should be opposite to each other. Got the point? Now let us come to the slide. I have here it is written very clearly in the slides. You can get the slides, right? You can get the slides. Whatever I have speak here in the last 10 minutes, it is written in the slide very carefully here. Now come up here. Then what are the methods we are going to implement it? First is called the bisection method. Second is called the Neutrino-Raphson method. Third is called the false position method. And fourth method we have second method, and fifth method we have total 4 methods. We have bisection, Neutrino-Raphson, false positions, and one is second methods. Here in GATE examinations, no one is going to ask find the root of this equation by bisection method. They will ask that at what condition bisection method fails. A, this condition, B, this condition, C, this condition, D, that condition. So out of 4, I have to decide. Don't expect that solved by bisection method, right? Or one may questions may ask in the GATE examinations that on what basis the bisection method depends on number A, number B, number C, and number D. Because once I solve one problem by bisection method, any one of you can solve it. There is no any difficulties. Anyone can solve it. Okay, so we have total bisections, false positions, Neutrino-Raphsons, and sequence methods. These are the 4 methods, majorly 4 methods we want to adopt to solve the transcendental and algebraic equations. Is it clear now? Now come up here. Bisection method, you can get a slide very systematic. That's why I want to write on the screen that how we can adopt the bisection methods, right? Now, after that, I can explain to you here. Now come up here, bisection method. Suppose bisection method. What is the meaning of bisection? It should be divided in 2 equal parts. If one word is missing, then it is very big mistake. It divide not only 2 parts, in 2 equal parts. अगर आपका equal word miss हो गया, it is big 0. It divide in 2 equal parts. Okay. Now, in case of bisection, condition 1. Be careful here that I am discussing here working rule, hence we can apply in the MATLAB programming. In between for and end, while and end, I have to write this equation, right? Along that some significance why we record here, because I have to write the interpretation. That's why I need a graph here. Condition number 1, the function should be continuous. Function means this is one of the functions, yes or no? A square or cos x plus ln x is equal to 0. This is one of the function. This is function, right? This is y is equal to f of x. Function should be first continuous. Okay. If it is not equal to 0, we have to first condition is that I have to make like this. I have to equate because I want to find out the value of this. Second condition, f of x should be continuous. Should be continuous. Now, number say f of a and f of b should be should be opposite in sign. It should be opposite in sign in the interval A and B. Why it is? Because just 10 minutes before we discussed that the graph should be cross-sected by x-axis, then only we can get the solutions. The two conditions satisfied. One, the function should be continuous. Second, the value of the function should be opposite to each other. Then only bisection method can be implemented. Then, if not, the program in the MATLAB programming, if not, it should be automatically show one warning that the functions are not opposite in sign. Now, how I can represent condition number C in MATLAB language? MATLAB does not understand if I speak f of x and f of a and f of b should be opposite. They don't understand how I can represent. Very good. Now, it means that or if I multiply this, if I multiply this, and if I multiply this, it should be opposite. Means there should be negative. Be careful that. That's why the translation from our theory to the MATLAB is little bit different. There is no options to write f of a and f of b are opposite in sign. So in if condition in the MATLAB, how to write? If I have to write if, right? If f of a into f of b is less than 0, right? Otherwise, the method is failed. So this type of condition has to be implemented in the MATLAB. Same thing here. In the ODE, whatever you have done the Euler's methods, modified Euler's, whatever you are doing the theory class, that language is human language, the machine cannot understand. I have to write in the MATLAB in different, this is called an algorithm, right? What is the algorithm of f of a and f of b is opposite in sign? Algorithm is f of a into f of b is less than 0. Have you got out what is the meaning of algorithm? The meaning of algorithm is like algorithm. To represent this theory in the algorithm, f of a into f of b less than 0. This is called the algorithm. So sometimes we become confused in that how we can represent our language in our machine language. Okay. Now I hope this is the two conditions we have to remember. Okay. Now come up here in my slide. If why it is put that if f of x is equal to 0, obviously should be 0. If there is no f of x is equal to 0, there is no meaning of solving this one. If this is 0, function is continuous in between a and b. See, I am not looking for the interior locations. I am looking for the interval a and b. It may not be continuous after that. This is called a local continuous, right? It is not a global. I don't want to take everything. I am looking for some particular interval. Is it continuous? Yes. Then I have to go next. What is the next? F of a and f of b should be opposite in sign. F of a and f of b are opposite in sign, right? Then there exists at least one solution in the interval a and b. This is called the bisection theory. Yeah. Sorry? At present, we are talking about the real roots. There is some another including the imaginary roots also here. But at present, we are starting with the real roots. Now, if I talk about imaginary roots, I have to little bit modify the methods. Okay. At present, very specific two things: positive root and real root. Now, if I talk negative root and imaginary root, the statement has to be modified. Real and positive root. Got the point? We are looking for real and positive root. We are not looking for imaginary and negative roots. Okay. Now, at present, if f of x is equal to 0, if f of x is continuous, if f of a and f of b are opposite in sign, then there exists at least one positive and real root. Is it clear? So now, before doing the bisection method, I have to cross-check now two things. It is continuous or they are in opposite in sign, in case of real and positive root, right? Now this condition, if it is satisfied in the graphical figure. I have very beautiful figures, but I hope it is better if I do here slides so I can get very good presentation here. Then I have to confirm the online guys sometimes slideshow is not reflecting in their system, mainly if the network is very much slow. Online guys, can you see my slide now? It is the blank slide. Okay. Now.
Yes, sir.
Very good. Now we are ready with our backgrounds. What is our background? We have discussed the conditions and statement. Now, bisection method. What is the meaning of bisection? We have to divide in two equal. Reason, maybe length, maybe whatever it is, the requirement. Okay. Now come up here. Suppose this is the graph. This is the representation graph. I expect that in examination, if question is coming, don't do this graph, you do different graph. It means you have created yourself. Now, because offline exam is coming, right? So don't think is that, say here, it is not necessary that this is the correct graph only. I can plot myself as per your choice, but take care that at least this graph is cross-check the x-axis. Look here, this is our x-axis, y-axis. This is the graph I have plotted. It is not necessary that I should plot this. I can plot this graph also as per your choice. And I give more preference those who are plotting different graphs in examination. Right? Okay. Now let us consider 2 points, xa and xb. Instead of xa and xb, if you take a and b, I'll give the more preference to you. Don't take xa and xb, take a and b. Right? Graph will be different graph, but at least it cross-check one time in the x-axis. X-axis take value of x, y-axis take the value of functions. Okay. Now look here. Look here very interestingly. F of x is continuous from the graph. Yes or no? From the graph, it is continuous. It is a continuous. Means first condition satisfied. Agreed? Now, second come up here. Positive and negative. F of xa and f of xb are opposite in sign. I don't think any difficulties here. Why we are taking this one? Our concept was that it should at least cross-check one sign, then we are confirmed. Engineers should believe the confirm. If they are not equally opposite in sign, if they are not in opposite in sign, we are confused. Maybe, may not be root. Now, first condition satisfied, it is a continuous. Second, the value of the functions are opposite to each other. Now we are confirmed. There is a root, at least maybe 10 root, but we are looking for one root. The question may be here. What is your requirement? Highest, lowest, what type of solution is required? Along with, I'll discuss the disadvantage of the numerical method also. From figure, it is very much clear now. What is the meaning of bisect means? I have to divide equal two part. What to do? I have to a plus b by 2. Then I can divide equal part. Right? The length is ax, xa, xb, add it, divide by 2. I can get equal to. Now look here, very interestingly here. I hope it is very much clear to all of you. Very clear? Very good. This is the root. Now, if I used our analytical method, means non-numerical technique, means our 10 plus 2 technique, by solving the equation, I can get exact this point. I can get exact this point. x square plus 2x plus y is equal to 0. If I solve, I can get exact 2 point where it is intersect. This is called the actual solutions. Now come up real engineering now. Why I talk every time that approximate solution and percentage of the error. This is the actual solution. What is the concept of the bisection is that now we are confirmed that in between XA and XB there is a solution. Very confirmed. What we are planning to do now, I want to divide in two equal parts, right? AX plus AB, what happened? Equal 2 parts. Look here. What we are doing, it should be very much clear in our visualizations. Otherwise, I cannot write the interpretation as an engineer. What is our aim? Look here. This and this values are assumptions, right? I have to find out the value of XA and XB in such a way that they are opposite in sign. In the way f of XA and f of XB should be opposite in sign. See, what is the input here? Input is the length of the interval XA and XB, and I have to cross check. Now, in manual it is difficult, but in the MATLAB it is not difficult. Just input it will do it is opposite sign or not. Okay, done, clear? Now, our aim is that I want to move from this point to this point. I want to move from this to this point. Is it clear? What is the engineering here? What is the physical significance here? I want to move from XB to Z, right? Where it is f of x equal to 0. I want to move from XA to the point where the function is intersect the x-axis. Our aim is here. Our aim is here. I have to reach here and be careful. In numerical methods, I never reach that point. I never reach this point. I will reach nearby. This is called a neighboring point. What the point? If you reach exactly means you are not doing this one. Right? We are trying to approach the neighbor of this point in numerical technique. I never reach there. I never reach the point in here. I can reach here maybe some millimeter near this. I may reach nearby this point. So that's why we can say about the accuracy level, percentage of the error. So this is the overall case. Now, what is the name? Bisection. It means that if I do the bisection, 9 meter become now 4.5 meter. Right? Now come up here. Now come up here. This I have discussed already, right? This thing see here. Just come up here. This I have discussed here. Just I have discussed in the just before 10 minutes with the example, right? Look here. F of these are positive. There is no root, but there is no root. But here roots are there. If it is a discontinuous, there is a no root. This slide are you have already, right? So that's why I'm skipping here. Don't feel that just skip the slide, not like this, right? This one means what? F of A. These both are same, but there is a root. Second, immediately, no root, no root. Got the point? Yes, yes. Come up here again. There is no, it is opposite because this is a discontinuous function, right? Now bisections come up here. Just I am not want to repeat here. Now come up here. This is called the bisection. This is called now algorithm now. In between 4 and n, I have to add the conditional statement if f of A into f of B negative, then I go with this equation. What is the xc? This is called the first iteration now. A plus B. I have the interval A plus B. What was the A? Lower limit. What is the B? Upper limit. F of A, F of B are opposite in sign. Means there is at least one root. What is the method? Bisection method. to how to do a plus b by 2. Suppose point is xc. Third point is very much interesting. If f of x is 0, it means what? It is a root, but it is not going to happen. Now, if the value of f of x is equal to 0, then xc is called a root of the given function at the interval a and b. Be careful. I am talking about interval a and b. So, in a reservoir engineering, you may heard that upscaling. I took small scale and I am upscaling up to reservoir volume. That's why we take the interval, small one, and upscaling it. You may confuse that I need the entire solution. In engineering, it is not possible. In engineering, don't expect that I have the function, find out all the roots. It is not possible. That's why it is called the upscaling. Take a small one and upscale it. So this is the concept in any type of engineering study. If I want to do the simulation modeling, okay, now if not, see my slide, I have put lots of here intentionally mistake. I want to cross check you. You are just taking yes, or you are just copy pasting. In my entire slide, once I do the classes numerical technique, my slides I put intentionally mistake, and I have some symbols are here. This solution is mistake. If you are telling that, sir, you are right, it means you are not doing anything. Because answer is because mistake. Right? Now, what can be there? I have the length A and B. Suppose it was 8 meter. After first iterations, it becomes 4 meter now. Now, if I divide the 4 meter, I have left side 4 meter and I have right side 4 meters. Means now A to XC, XC to B. Now I have to decide where it is. Either it is in first interval or it is in second interval. Clear? So this is now look here. Otherwise, the root lies in between A and XC. At what condition? Is it correct condition, minus? Don't tell any yes. Yes, be careful. So I immediately pick up that you are not giving attention in my class. It's a theory class, I do that. Once become it is offline class, everything will be different. Right? I never get it to offline class, right? Once become offline class, everything, and those who are doing only, they will get the present. I'll move here and there. Right? If you are not coming here and sitting here, you go outside and sit there peacefully. I don't want the answer correctly. I want that you try. Answer nahi aaya hai, koi baat nahi. But you tried it. So be careful that my answer is not coming, but I tried it. I made a mistake because I tried it. I made a mistake, you did the mistake because you tried it. You are not doing anything means you are absent from 14th of March. Right? This is my logic. Okay. Now is it clear? We have two options now. If f of xc is 0, then xc is the solution. See, try to understand because this logic has to be applied in the MATLAB. I have to apply the MATLAB. Now, what is the two options? Either the root is in between interval A and XC or XC and B. At what condition? C are opposite inside. See here, inside it, again I have to use the if else if. I have to apply now. If else if. Now here, if it is not there, either it is here or here. Right? Is it okay or not? Right? F of xc and f of xb are if opposite, then there is a root. Logic is clear now? Yes. So we had one interval Now I have two intervals. So I have to decide this or that. I'll explain with the help of graph in the next slide. Now, the process will continue, means I will apply the for loop. Got the application of for loop? The process will be continue until we can get specific tolerance. Meaning of this, every calculations we have tolerance. What is the meaning of tolerance in dictionary meaning? If I try to understand the meaning of tolerance. Yes, means bearing means I am not writing here exactly number, because if I do this is in the reservoir, I have some specific tolerance level. If I do in the while logging, I have some specific tolerance. So this for loop will do now. Now I don't know how many states. That's why I use the while loop. I'll define the tolerance. I'll define the tolerance. This is my tolerance level. Error should be 10 to the power minus 10. Then loop will be stopped. Now for loop में क्या होगा? Just give the range I1 to 1000. So this is not possible. Use the while loop. Use the while loop. It become automatically stop because I know this one. Now try to understand with the help of graph now. After that I'll stop the class. Very good time for the class, but we don't have any options because in the online we joined and we can sit in any position, right? But in the classroom we cannot sit in any position, right? In the classroom we cannot sit in any position. That's why in the beginning level it may be difficult. Last 2 years I sit any positions and some I'm sleeping like this, but it requires some time to maintain the disciplines. That's why offline is required. As a passer, as an engineer, along with this knowledge, I have to learn the discipline also. How to speak, how to sit, how to behave. That's why class is required here. That's why in the beginning, I told you that it is a classroom. These are guys of, I think, I don't know, from HLS, I think, don't know. These guys are. If I was there, I never allowed to enter in my classroom like this. I kick out them. Right? Now, come up here. After that, I'll stop it. Same graph I have brought up here. The graph should be different if you write any answer. It should not, it may be different graph. Draw it. Why you are taking only my graphs? Why you are copying my graph? Don't copy that. Now look here. Positive, negative. Now be careful here. This is our XA and this is our XB. Graph is continuous as per the figure. Graph is continuous as per the figure. All conditions satisfied. Now find out very interesting XC. It required lots of time to prepare the slides. But once I did, it is useful for you and easy for me. Right? Now, have you got XC? This is the graphical representations. It may not be exactly here. Got XC? So I have two intervals, XA, XC, XC, and XB. As for the graph, what is the solution? In which interval? In between it is XC and XB. Have you seen how it is beautiful in see the graphs? It means in between XC and XB, there is an intersection. That's why as a petroleum engineer, by looking the oil log, I have to interpret. There is a cell, there is a limestone, there is a hydrocarbon. That will help to you in the graphical representation. Okay, clearly figure shows that the root is in between XC and XB. Then what to do? Then the loop is continue. Means suppose now I have to add XC plus XB divide by 2. Yes or no? Yes. Now come up here. What is FC? Positive or negative? It is a negative. It means that f of XC is negative, f of B is positive. It means there is a root in between XC and XB. What is the algorithm? XC plus XB by 2. So I did here. What will be the next? interval. It is xc and xb. Okay, now come up here. This is the interval. There is a root. It is reflected in the figure very clearly. And the value of f of xc also negative. So there is a root. Now, next, suppose if I divide it, it may be somewhere here or here. xc1 is. Right? It means that we are trying to approach kaha jana hai, where the function is intersect the x-axis. Means we are approaching towards the point where the graph is intersect to each other. Right? Intersect the x-axis. I hope now if somebody asking that what is the algorithm of the bisection? Algorithm is we are approaching towards the point where f of x is equal to 0 by dividing the length in equal two parts. So it was 8 meter, become 4 meter, become 2 meter, become 1 meter, divide it until our specific tolerance is reached here. Okay, now this concept, I think we don't have time now. Now, this concept, what is the step number 1 here? I have to identify A and B. Right? What is the conditions I can identify A and B, and what situations A and B will be my interval. And at what basis I'll decide this is my A and this is my B. F of A and F of B should be opposite inside. Now, if I modify these questions, find out the positive and smallest root of the, how many roots here? 3 roots. But I'm asking for positive and smallest root. Now, somebody asking, what is the disadvantage of this method? The numerical methods can give only 1 root in 1 time. Right? The numerical methods here, bisection methods, neutral reductions, point positions, whatever it is, will give 1 root out of 3 in 1 time. If I require other 2, I have to do 2 more calculations. So this is the big disadvantage of this method. At 1 time, I can get only 1 root. If I require 3 roots, I have to repeat 3 times. Is it okay? It is very easy, very simple to understand this one. Okay. So today we'll stop here. Okay. Today we'll stop here. Tomorrow I will take a tutorial because yesterday we have lab classes. So 3 p.m. we have tutorial. So tutorial class will discuss our remaining topics, right? Improvement solutions. Okay. So unit number 1, it is very much interesting. You just prepare for the GATE exams also simultaneously for engineering mathematics. Okay. I also try to help you how to prepare all these things. Okay, please join online and I can take the attendance. Thank you very much.